Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how you can take a basic body plan form of a ship and turn it into a 3D mesh that you can use for a hydrodynamics analysis in a seakeeping or maneuvering analysis tool. So we're going to use Rhino today for this and eventually put it into our software ProteusDS and the ShipMo3D toolset just to show the workflow process of how you go about doing this. Now, why would you want to do this? Well, sometimes you don't have a lot of documentation about a particular ship that you're interested in. It might be for like a refit, or it might be an older vessel, and you just don't have digital files for it, but you do. Usually there's a body plan somewhere, right? You might also be inspired by a similar kind of ship design that you want to work with, and you found a basic information on a body plan just to use as a starting point from which you want to mold something into something new, right? So this is a quick way to get something going. And yeah, like I said, we're going to use Rhino today. Now, the other thing is sort of validating this. We need to get a body plan to use as a demonstration, but kind of handy. We have one that also is part of a validation data that we have. So we have confidence in what we're doing. So if you go to the ProteusDS.com website, under Learn, and then Documentation, I'm going to open this in a new tab here and scroll down to ProteusDS ShipMo3D Toolset Validation document, and we open this up. And one of the most important validation cases we have is the full-scale data set measured from the destroyer Nipigon years ago. And fortunately, we have all the particulars here. So this is also reflected, like you need to know a little bit more information than just the body plan here. But here's the body plan. We need to know the lengths, we need to know the maximum beam, and we need to know the number of stations, although usually that's something like 10 or 20, a common number, because you're going to need to know the station spacing. So we have here the particulars of the Nipigon, the length, and the maximum beam. And this is the body plan. We're going to use this body plan and go for it. So I just made a little screenshot there, and I'm going to save this. Desktop vessel projects, Nipigon body plan. So here's my little working folder for this project. We don't need that anymore. And in terms of validating, the Nipigon project files are publicly available also. So this picture that we're looking at here is the meticulously assembled ship motion project of the Nipigon that's used in the validation project. It's publicly available, so you can use it to compare. Now, when you run panel hull in the ShipMo3D toolset, you'll see outputs like the displacement and metacentric height and all that kind of stuff. So we can kind of compare that and make sure that we're in the right ballpark. And this might be something that you can do if you have stability book information. You can sort of like tweak the fairing of the ship. And obviously you can put more time into it to get it to what you want. We're just going to do a rough process to demonstrate like how you can get going relatively quickly. Okay, so I mentioned we're going to use Rhino. I have Rhino open here. I'm just going to double check that we have large objects and meters selected here. And the first thing you need to do is bring in the body plan picture, because we're going to literally draw the lines from the body plan in here, and then we're going to use the sweep command to make the hull form. And from then, that surface that we have, we can make quad remesh, make the panelized hull that we can use for the hydrodynamic analysis. We're going to use the picture command, and it's going to say which picture do you want to load. We'll put it in here, and now I want to put it in the ZY plane here. And I want to do that because the reference frame orientation that works best with the ShipMo3D toolset is getting everything aligned on aft perpendicular and baseline. Aft perpendicular at x equals 0, baseline at z equals 0, bow towards x positive kind of thing. I might recommend you sort of make use of your layers. So we've got this active layer now just by clicking the checkbox here. Let's make sure the layer is actually in there. So we select the image and right click and go change object layer. Now this is kind of nice because we go back to another layer. Later we can turn that on and off just really easy, right? Okay, so we've put the image in here. The big thing we need to do first is make sure it's the right scale, right? So what did it actually turn out to be? what we'll do is we use the distance command and look at sort of like really roughly the maximum beam sort of around here to here. So that's 24.2 meters. And that's just what I pasted it into the Rhino project. Now what we want to do is apply a scale factor to that. So the actual beam is supposed to be 12.8. So we'll go back here. So 24.2, we're going to go scale. And I already selected the image, so this is all right, what do we want to do? Base point, I don't actually really care about the base point, so I'm just going to press enter. Now the scale factor, you can put math in here, which makes life a little bit easier. So we want 12.8, and then we're going to divide by, now what was it we measured again? 24.2. Okay, so now we'll just double check again to make sure with distance that we've got the right beam, just as a reality check. So we go here to the other end, length of the beam here, and we got 12.8. So like, you know, we're within the thickness of the line drawing here. This is looking pretty good. Now the other thing we want to do is move this in the right position. So I want to have the keel right at z equals 0 and y equals 0. So we have the center line there. So what I'm going to do is go move, point to move from. I'm going to pick right there, and I want to move that to 0, 0. And things are looking pretty good. So I'm gonna save this now. Vessel projects, just to save our projects here. Body plan work. All right. Okay, so there's enough steps in here. I've written some notes to help me go through this process here. But yeah, okay. So what we want to do now is literally trace those lines from here into. I'm going to select a new layer here, and we're going to rename this layer hull lines. Okay, and yeah, it's just we got to go through a process of drawing the hull lines on here. So what I'm going to do is I'm going to use a polyline. You might experiment with different line forms. You know what? I'm going to deselect just to get the lines off there from that. Okay, so we'll go polyline. And I might suggest also you turn off O-snap. We just don't want the lines snapping on each other, and it's kind of irritating when it's doing that. So I'm going to get it kind of close to the center line and baseline. It doesn't have to be perfect, but we'll start with the front shape here. Now it doesn't have to be perfect. Again, you can spend the time that you want to try to get the resolution that you kind of want. Go there. Oh, and the whole thing here. That's one hull line. We'll do it again. Later, we're gonna snap the end nodes right on the exact y equals 0, but we'll just kind of roughly get this going here. I found polylines pretty easy to work with, but you might have some luck working with different line model elements. In Rhino to get the smoothness and the curve that you want. Of course, once you have the surface, there's a lot more that you can do. Now, I'm going to be a little bit lazy and not do every single line here, but I generally want to give you the idea of like what's happening and the process to follow. So we'll kind of, this is bulging out here a little bit. Okay, I'm going to draw a couple more lines, and I'll be back in a moment. Okay, so I've drawn some more lines. Now this is where it's kind of handy using the layer settings in Rhino. You can see if I click the light bulb on body plan, then we're just looking at the polylines that we've drawn, which is kind of nice. One other note here is that this technically doesn't include some of the bow form from the body plan, so I've added a couple of lines, a bit of artistic license there, but what really matters is having the wetted hull area, and this isn't going to really affect the nominal displacement or metacentric height. Now I mentioned I'm not doing every single hull line. Again, this is kind of demonstrating the process, but we got a pretty good number there. It's also kind of demonstrative of like, you know, you don't need, it doesn't need to be perfect, right? Okay, so now we've drawn all these lines. However, the thing is, they're all still in a plane. Now, this is where the number of stations and station spacing come in. So if a length of 104 with 20 stations, that's 5.4 meter station spacing. So that's literally all we're going to do right now is move the lines that we've drawn to the right spot. So if we start, like, say this is at station 20 here, we're just going to go to the move command. Select objects to move. So we've got this one, curve. Press enter when done. Okay, so point to move from. Now we're going to use the relative command because it's kind of a little bit easier to work with. So I'm just going to press enter, and this is point to move to. So what we want to do is go R for relative. Okay, and then we're going to do 20, like as in station 20, times 5.4, comma 0, comma 0. And press enter. Now, that looks about right. So we've got the line there, and we're just going to systematically go through and do the other lines. So we select the next line, move, point to move from, enter, and point to move to, R for relative. I'm going to do this in brackets here, 19 for station 19 times 5.4, comma 0, comma 0. And I kind of think you get the idea of how this is working. So I'm gonna keep working on this, and I'll be back in a second with the lines all spaced out. All right, so I've offset all of the hull lines. Now, what I'm going to do is turn off the body plan here, and you can see we had some from the front looking stern and from the aft looking towards the bow, right? And I've got them spaced based on each station. These bow lines, I added them further forward of station 20. Obviously, it helps to know a bit more information about that. But yeah, you gotta just try to do the best you can. So now at this point, what we want to do, there's a couple things we want to do. First, we want to get all the lines on one side. So that's pretty easy to do. I'm just going to select the line there and hold down shift and select the rest of them. And we're going to go mirror. And we're just going to pick the x-axis. And it's mirrored the lines, maintaining selection on the remaining ones. Now we delete those old lines. So this is just, we need to have all the lines on one side because we're going to do the sweep command through everything. Now, maybe it's a good time to save the project. Now, the other thing that we want to do is make sure that we have the nodes along exactly y equals 0 along here. Now, we want to do that because we want to avoid having any gaps in the surface, any holes in the mesh, really. And there's a couple things you can do. You could draw more polylines, or you can just move the nodes accordingly. Now that's what we're going to do. And first thing we're going to do is turn on control points. Now you can hit F10 to do that. And use the command. And it's just a little bit easier. Select all. No, not mirror. Points on. Select objects. Yes, there we go. So now you can kind of see, you know, I've got, what I'm going to do is move the nodes exactly on y equals 0. Now, if you know that the nodes are supposed to also be on the baseline, you can move them to z equals 0 as well. Obviously, at the transom area, those should not be at z equals 0, though, of course. Yeah, so that's what we'll do. I think it's pretty close to z equals 0. Mainly the main thing we want to do is get y equals 0 on a lot of them here. So what we'll do is you can select more than 1.2 as well. Curve point, holding down shift. And then we'll go set PT, set point. And we'll go set Y. I'm not going to bother with a Z right now. I don't think it quite matters as much. It might help make a more smooth transform here. So we go set Y, and we want those to be all 0. Enter. Great. Similarly with these ones, we didn't do these ones. Set PT, set point. And we'll go 0 for Y only. And we did those ones. Let's just make sure we're picking the node there and shift select there. Set PT. Now you could probably do faster, quicker things with filter selects and things like that. 0, but we're not going to do that today. Set point Y 0. Okay. It may not look like things changed much, but again, this is going to make sure that we don't have any holes along the mesh. Okay. So now the other thing that we need to do here is to use the sweep function. Now there's a bunch of other functions in Rhino for making a surface. I found sweep2 works pretty well. To use the sweep function, we need to have 2 rails for the sweep to follow along. So we're going to make a new polyline. Oh yeah, and it's probably good to turn on OSnap here and make sure we have end and vertex selected. So we make one rail line that goes along the top of all of these lines here like this. And of course, if you had more hull lines, you would draw through all of them. So that's one rail line. We'll do the other one along the bottom here. Let's make sure we don't miss. We want to get all the lines along the very end here. I know there's going to be some inaccuracies in this form because we've only used some of the hull lines, but this is about demonstrating the process. Okay, so now we've got our rail lines. So we go sweep 2. It says select the first rail. There's our first rail. Select the second rail. There's our other rail. And it says, well, what are your sweep shapes? We can just kind of select everything in there and go enter. And that's like the bulk of the work in terms of making the surface, really. Now, there's lots of settings here. I kind of found it looked better if we rebuilt the cross sections option here. You could probably play with a lot of those for a while to get it looking how you want. I know it's not exactly looking the way that we want 100% because we're missing some hull lines, but you know, this is pretty good for a quick and dirty idea here. Oh, let's move that surface into another layer. You know, maybe we'll move it into the default layer. So we're working in the default layer. We've got the checkbox. I've got the surface highlighted, and we'll go change objects layer there. Okay. So you can see the back plane coloring that we've configured for viewing normals the right way as well. Now I'm going to turn off the hull lines layer because I just want to be looking at the surface, and we're getting really close to finishing here. So now the other thing we need to do is add a transom. So one thing that might make this a little easier to do is if we mirror this, we'll do x-axis here. So we're kind of, things are kind of looking pretty good here. We've got a little gap in the front here. We could fix that, but I know the water line is going to be somewhere down here, right? So we're not too worried about that, but we got to deal with the transom. I think maybe it makes it a little easier if we join these. So I'm going to go show edges here. It just kind of shows edges a little bit easier for when we add a cap. Now there's more than one way to add a cap here. I'm going to make a new polyline to facilitate making the cap. Enter. And we're going to use the planar surface. I think you can use patch too, but we'll do planar surface. Planar surface. Okay. Select curves. So we'll go this curve, and that polyline. And for a nice flat transom, that's pretty good. So I'm going to go enter. And let's turn off the edges. We don't need those anymore. I'll move this hull line, this polyline we made here. Well, we don't need it anymore. And let's move that into curve. Into hull lines, change object layer. Great. Okay, now we want to flip the normals on this. So you can go dir flip, F for flip. There, that looks better. We want the normals to be on the inside for, I mean, it's more important for the mesh, but it's going to help to have the surface set up the right way as well. So we're going to save this right now. Now at this point we're basically done what we wanted to do. You can follow other video tutorials on making a quad remesh of this, but for completeness, we'll just do that and kind of do a comparison with the actual Nipigon project over here and see how far off we were. I do expect to see differences, but the idea is with a few minutes showing you what's going on here to see how fast and far you can get. Now, there's things you could do to improve the fairness of this, but that's kind of out of the scope of what we're talking about in this tutorial. Okay, so what we'll do is, now for the ProteusDS ShipMo3D toolset, we need to have the port side of the vessel. And so what we're going to do is we'll save this and we're going to go make a little cutting plane. And we're going to go trim, select cutting objects. There's our cutting plane. Great, all done. Delete that, and let's make these joined up as one. Okay, so now we would go quad remesh. I'm just going to do a really crude, quick model here with 1,000 polygons. It's actually pretty good. Generally speaking, it's looking like it's meshing pretty well with the geometry. So that's what we're going to end up with. Faithfully making a mesh pretty close to our surface. So we'll go OK. And now that's our mesh that we're going to use. So we'll go save as and obj Nipigon. So we'll go save. And remember, make sure you uncheck that map Rhino Z to OBJY. Sometimes it shows up by default when you've installed an update, but it should save your settings. So we're done with Rhino. Now, I've got the Nipigon project here. Let's make a brand new ShipMo3D toolset project. Because what I want to do is load the mesh and then just show you the difference in displacement and metacentric height based on this quick and dirty mesh we made here. So vessel projects, body plan Nipigon, we'll save that there. I'm just going to copy the particulars from the project here. 108.5, station of aft perpendicular, draft at midships 4.245, trim 0.496, height of CG 5.081, and these other parameters here. Okay, save. So we'll add new data. Panel hull, and we want to do the wavefront OBJ. There's our OBJ file, and we'll go save and run. Okay, so I can see that it's picking up that there's some vertices with an ever so slightly negative Y component. That's kind of the issue here. Sometimes when trimming a mesh and generating a mesh after trimming the surface, you can get a little bit of deviations. So I'll show you how to fix that real quick. If we go back to Rhino, so here's our mesh. So we just hit Control Z, undo, undo, and we'll actually work with the entire ship this way. First, you could do, it doesn't always happen. It's just one of those little sort of finicky things. So we have the surface, we'll join that up there, and we'll apply quad remesh to the whole thing. The other benefit to this actually is we can pick a symmetry plane. In some case, that's you have to do that for some challenging hull shapes. So we're still just going to pick 1,000. Actually, be better, more computationally efficient this way because it's spreading 1,000 over the whole ship. And that looks pretty good, so we're going to hide. So now what we do is we apply a trimming action here. And this for sure will guarantee that we have all vertices in without any negative components crossing the Y. So we'll go mesh trim, select cutting objects here, and we're going to trim off that portion. Okay, all done. We'll delete that. Okay, so there's our mesh of the Nipigon, and we're going to go File, Save As. Just save over that OBJ file. Everything is looking good. And then now we go back to our project, and it's the same OBJ file name. We just got to rerun it, and we're good. So we'll plot panel hull, and I like the ship parts because it shows the wetted hull area. So see how the wetted hull area is quite far below the bow. Like the bow is not going to affect things that much. That's why I was not too worried about closing it and so on. And you know, just visually looking at it, like it's pretty close. Obviously, this looks nicer, but this is a pretty quick and dirty example. Now, if we look at the view output here, we've got some particulars we can compare with. On the proper file, we see we have 3,005 tons, we're 2,800 tons. Like, you know, it's a little bit lower. Metacentric height 1.3 meters, 1.24 meters. So, you know, obviously as we added more detail in the hull lines, we'd get a lot closer to it and maybe work a little bit on fairing it, smoothing out the hull. It would look good. But generally what I wanted to do is just show that idea of how to go from like this rough 2D drawing to getting a hull and, you know, having some confidence that this is going to work. So that's all for now. Thanks for watching.